Hello, my name is Osnak August, and this video is my code review for CS499 Milestone 1. For this milestone, I am reviewing and analyzing the project I completed in CS340, which was the Gracio Salvare Animal Rescue Dashboard. And this project includes two main components. The first is the Python CRUD module that interacts with a MongoDB database, and two, the Jupyter notebook dashboard that filters, analyzes, and visualizes the animal data. I chose this project because it gives me a chance to demonstrate skills in all three required categories: software engineering and design, algorithms and data structures, and it makes use of databases. And I will be going through it, analyzing the code, using the review criteria I was giving, and explaining the enhancements I plan to make in all three categories. Let's start with category one and start this. So, from the software engineering and design perspective, so the main component is my CRUD module, which is right here. And in this module, it includes a class that connects to my Mongo database, the methods for creating, for create, read, update, and delete, and logic that isolates the database behavior from the dashboard. The dashboard uses this CRUD module right here. The dashboard uses this CRUD module, and calling its methods whenever the filters uses animals, loads data, and updates records. So the design separates data access from display logic, which keeps things modular and easier to understand. Let's go with the code analysis. Let's analyze the Python CRUD module. So the CRUD functions are organized within a class, and the dashboard relies on a single interface for database operations. So the project avoids duplicating logic, query logic, all over the notebook. There are some issues and limitations with this, of course. For example, some functions try to do too much at once, like building the query, querying the database, and formatting the results inside the same method. Another thing that's limited is error handling. So if the connection fails, there isn't much feedback. And configuration values like the URI and the database name, as well as the passwords, we can say they are all hard coded. And as we see here, the comments and doc strings are also minimal, which makes maintenance a bit harder. There's also no logging, which we all know is important to trace the database operations. So, from a design standpoint, these are issues that affect maintainability, clarity, and scalability. So to enhance this, what I plan to do or what can be done is to refactor the CRUD class so each method has one responsibility, moving configuration into a config file or environment variables, adding structured error handling with try and except blocks, including logging for key operations, adding doc strings and comments to make sure that we explain each method's purpose. So these enhancements will help me demonstrate a stronger software design principle once they're all added. So that was that for the first category. For the second category, which is algorithms and data structure, let's take a look. So even though this isn't a traditional database and algorithms project, it includes several areas where data is processed, filtered, and transforms. So for example, I load animal records into Python as a list of dictionaries, and I prepare subsets of the data for charts and visualization. In some parts, I convert data into pandas data frames for easier grouping and counting. So the project uses loops, conditionals, list operations, and sometimes data frame to help the data into what the client needs. So here are some strengths and limitations that we can notice from this. So the filtering logic is clear and easy to follow. Python's built-in data structures work well with MongoDB documents, and some transformations uses pandas, which simplifies grouping and visualization. Uh, the limitations, which include because filtering is done in Python after fetching all the documents, that can be really inefficient. Some filter logic is repeated instead of abstracted into, we can say, the helper functions. And for large data sets, pulling everything into memory isn't ideal. And as we said before, the comments are really sparse, which makes maintenance a tad harder. And it might not make the methods and what I'm trying to convey clear. To enhance this and make this a little bit better, what I can do is move the filtering logic into the Mongo query itself. I can create helper functions to avoid repeating filter logic, standardize how I structure immediate data, for example, deciding when to use lists versus data frames, and add comments, of course, to explain the specific rules and what I'm doing and what the client requirements are. So adding on these enhancements better demonstrate algorithmic thinking, performance awareness, and effective use of Python data structures. And category 3, last but not least, is databases. So in the database category, the CRUD class is again the main artifact. The class currently establishes, as you can see here, it establishes a connection to the MongoDB right here. And then it executes read, create, update operations and return results to the dashboard for visualization. The dashboard calls the methods with different queries, we can see here. So it calls these methods with different queries to support the client needs, like identifying, search, and rescue animals. So everything in a dashboard depends on what the database returns. When we're looking at the code, we can analyze it and see the strengths and some of the weaknesses and maybe even issues and risks. So some of the strength is that all the database interactions are encapsulated in our CRUD class, like we saw, and the CRUD functionality works reliably based on the project requirements. Queries use Mongo's standards and operators. So the issues and risks that we can see here where we can actually optimize is our passwords and usernames or credentials. We can say they're exposed in the code, and some queries are just too broad, meaning the database returns more data than necessary. There's limited validation of inputs before they reach the database, and error handling doesn't clearly explain what went wrong if the operation fails. To enhance this, to make it better, for the database category, I plan to move the database configuration and credentials into environment variables, validate the data and the query objects before passing them to MongoDB, optimize queries to only request the fields and records needed, and add database specific error handling with, we can say, clear messaging, and of course add more documentation in terms of comments and what the database actually is actually doing. So these enhancements demonstrate secure database access once implemented, efficient querying, and reliable data handling. So to conclude, by using this CRUD module and dashboard as a single multifaceted artifact, I've been able to review software engineering and design, algorithms and data structures, and as well as databases. I identify the limitations and propose enhancements that will make the project more maintainable, secure, efficient, and aligned with real-world expectations. and this will help me demonstrate the CS499 course outcome in my final portfolio project. Thank you for watching my code review.